Okay, these are the last two objectives of Module 8. So both of these are actually like practical side of things. So you will find other videos and other links that'll be showing you how to do things in creating the map. So so just bear with me with trying to like just go through the theoretical components of the application, and then you'll be working on your maps. So here is the how do you collect data for a map. So you can use pretty much anything to get data. In our class, you're going to be using an aerial photo and you're going to digitize it, but you're also going to collect GPS data and collect that and put that in there as well. So, and the aerial photo can also be from ArcGIS Online, so it comes from a satellite and then they do a aerial photo. So depending on how much you zoom in is what you're going to be digitizing. So whether you collect data from the internet, you get it from an aerial photo, you get a table somewhere, you get data from somewhere, you need to tell me where you got your data. I'm emphasizing that again. I've told you that before. I'm going to tell you it again. Tell me where you got your data. I know even if you get it from me, you say, I got it from Karina Butterworth's Maps 204 data, lecture, Karina Butterworth's Maps 204 online system D2L or whatever, and say you got it from my course. Make sure you tell me where you got it because it is important. And I know that at this time you're like, well, I'm just in school, but no, it's important. Okay, I know you're just in school, but we're preparing you for industry, and so you need to have this information there. So I'm a real stickler about this. Always include your author, date when you acquired the data, and the website that you got it from. Okay, so yeah, let's say you go to a website to get information. Write down who made it, if you can find that information, the date you got it, and then give me the website address. So generally speaking, most maps use an APA format. I allow IEEE for my stuff if you want to do that instead. I'm not even really all that picky if you don't want to use those particular formats. As long as you give me the information I need, then I'm happy with that. So I don't care how you collect data, but you got to tell me how you got it because it's really, really important that you tell me that. The other thing is collecting GPS data. So when you go out to collect GPS data over an area that you are working on, you need to be aware of error values. And in this class, I don't get into a lot about GPS, and I would like to do more, but I don't have the time. So when you're collecting GPS data, you need to look at the data. So there are some particular information that I want you to know, and there's ways that you can get like the predicted information. There's websites available for that. So there is something called dilution of precision, and it is exactly as it sounds. So I dilute my precision, which means that my precision gets worse. Because you can imagine precision is everything like really close together, a high precision. If you dilute it, the points are spreading further and further apart. So that particular measurement tells me, how close together the GPS measurements are being made in terms of like the actual satellite talking to the receiver that you are holding on to. Because it's kind of constantly giving information. And so the dilution of precision tells me the error in that area that you are trying to get information. Some software allows you to get a predicted accuracy, so especially handheld systems, say, hey, you're getting like a 3-meter accuracy or you're getting a 15-meter accuracy. Write that down if you have that. Of course, it's going to bounce around, but when you take a measurement, take a look at the accuracy and then write it down. Okay, so that's important. Also, you can look at satellite accuracy. So this satellite accuracy is how many satellites do you have and which satellites are you using. So when you go out and you're documenting field notes, you have to write those things down because if your DOP value is really high and you only have like 3 satellites, you're actually really not taking a reading. Like that reading is missing information, so it is in the wrong spot. You might think it's in the right spot and then you take it back and you find out it's in the completely wrong location. So it's really important that you document all of that. When you are in the field and you're taking a GPS measurement, take the equipment that you're using and put it over top of the point if you can. In our exercise or assignment, you're not worried about height, so I'm just more worried about location. So don't get too hung up on about the height. It's like, oh, well, how high do I hold it? Do I hold it on top of it? Don't worry about that. We're just looking at X and Y in this case. But make sure it's on like over top in the center as best as you possibly can. And then if you need to be offset, like so you can't actually get to it, such as like a tree, it's really hard to get into the center of a tree. And so you can measure out, use a measuring tape, measure out in a certain direction, and like maybe towards the sidewalk or something. And then you can document that I offset 5 meters because the tree under the tree it wouldn't let me see satellites to that point. So that is those are a few like little tips that will help you when you're collecting data. Make sure you always write down the equipment and or the app that you're using to collect the data in your field notes and on your map. Again, that self-referencing is really important. And include the date and when you collect your data. This is so important because what if something changes in between you collecting the data and you publishing the map? And then somebody's like goes back and they're like, I made this change out in the field and you didn't document that. At least if you have the date on it, then you can say, well, this is when the data was collected and it wasn't there before. So it's really important that you do that. Again, everything I teach in this class is really important, but when you're collecting GPS data, you have a lot to write down. It's not as easy as just like mark waypoint and keeping going. Okay. So going into Objective 8.8, this is using software to create a map. So in this case, in this class, we're using ArcGIS. So there are two different kinds of ArcGIS nowadays. There's something called ArcGIS Pro, and then there's like regular ArcGIS. So I'm okay if you use either. You're welcome to use either one. I will be showing you ArcGIS Pro, and I'll try to show the other version, like 10.7, I think they're on. So we'll include that. But in ArcGIS for this class, you are going to digitize an aerial photo with points, lines, and areas. You are going to set up a geodatabase to contain that information. Then you're going to ensure that each type of feature can be clearly identified. So you're going to change the symbology. So watch how I change the symbology in the video when I present that. Then I want you to identify between the same types of features using symbols, colors, and sizes. So for example, manholes and fire hydrants and light bulbs must be separated. They can't be the same symbol. If you want to show between different buildings, for example, maybe you might show different colors. Maybe you might show, if there's fire hydrants and trees, you might use a tree for trees and a fire hydrant for fire hydrants. It's pretty straightforward. So take your time with it. Make it look as professional as you can. I'm not expecting perfection, but I'd like you to be careful with it and try to make it look good. And in the video that I show you how to use the software, I will also show you an example of what I expect. So in ArcGIS, you need to bring in your GPS data as a separate layer. You have to have collected it as like UTM coordinates. If you collect it as latitude and longitude, then then this isn't going to work, and you're going to have to like hand calculate using some software online, like the conversion between going from latitude and longitude to UTM, because ArcGIS is going to have a really difficult time between using two different coordinate systems. So you may notice that some points don't fall where they should be. This is because of the GPS errors. So I want these points to be in the wrong spot. And the reason I want these points to be in the wrong spot is because of the fact that I want you to see handheld GPS is not as accurate as they try to make it sound. It is not that accurate. In fact, a good handheld GPS is about 15 meters accurate. Okay, so this is, and that's like really good using cell phone towers. Okay, like the triangulation with cell phone towers plus GPS plus Wi-Fi mapping, it's still only about 15 meters. You can get down to like a couple meters. It'll tell you the accuracy is about a couple meters for the satellite, and that's great. But the actual location is probably out by a minimum of 3 to 15 meters. So that's something to keep in mind. I want to see the difference. I want to see the difference between symbols that you collected with GPS and symbols that you were digitizing. So you're going to be going over the same area. You're going to be collecting the same information and creating your map with that. You may have to put your GPS points into a table in Excel before importing it into ArcGIS. Your columns need to be named this way. So if you are using a special like database software, make sure that there are these code or these titles in there. So point ID is just really like whatever number you want to come up with. You can number them however you like. Then you're going to have your easting value in UTM, your northing value in UTM. You're going to have like a description, just describing the point with anything that's valid. So it might be like fire hydrant by the really bushy tree, or it could be, you know, broken sidewalk area or whatever. I want you to be descriptive of that so that it's something you're like, oh yeah, I remember picking up that point. And the code is something that you're going to identify similar objects. So for example, fire might be fire hydrant. Use just 4 letters. Don't separate between them. So if I have 10 fire hydrants, I am going to call all the codes are going to be fire and watch capitalization. What that does is it allows it easier to group things later when you are trying to show symbology. So it makes your life a lot easier. So when you're doing that, keep those in mind. And your GPS data will come in, and I want to see them separate. Then ArcGIS itself, what you're going to do is symbolize your GPS points based on the code column. So that's why I want you to keep them with that. And then include all basic elements on your map. So make sure that you include the title, the legend, the north arrow, etc. Watch for the cartographic principles, so that little bit of art that's added in there. And then you're going to export the map as a PDF. So you can either export or print to. Both of them work, and you'll be able to do it with that. So again, with ArcGIS, I will have videos, and you will see videos up with how to do this or links to how to do it online. So like YouTube videos, because sometimes they are just as good as what I would be able to show you. And then use the discussion thread for any issues that you have, because then we can give you a hand and help you out. So that's everything for the GIS, well, I guess the GIS module. And then next module is looking at photogrammetry.